Hello and welcome back, everyone. I'm your host, Nathan Peck, and today we have a very exciting announcement at the intersection of serverless and machine learning. I want to give our new guest host, Steve, a chance to introduce himself now.
Hi, I'm Steve Roberts. I'm a developer advocate working in the EC2 team for .NET and PowerShell. And we are joined today by Ram and Rushab, who maybe like to introduce yourselves.
Hey everyone, my name is Rishabh. I'm part of the SageMaker Inference PM team.
Hey everyone, I'm Ram. I'm an ML architect on SageMaker Serverless team.
Awesome. Well, I've heard now both of you working with SageMaker, so I assume our announcement has to do with SageMaker. What is the service and announcement that is launching today?
Right. So we are launching SageMaker Serverless Inference, which is now generally available. It's a new inference option within SageMaker, which makes it extremely simple for customers to deploy models into production. It's a serverless inferencing model through which customers can deploy really quickly, and they do not have to manage any of the underlying infrastructure because it's serverless. And they only pay for what they use, and they do not pay for any of the idle time. So it significantly reduces the cost structure for any of the intermittent kind of workloads.
Well, so naturally the question pops up. I just want to make sure everybody's on the same page here. What is this inferencing that we speak of? Like SageMaker serverless inferencing. What is the inferencing part? I know it has to do with machine learning. I'm not super familiar in this space though. So if you could explain a little more about the context there, I think it'll help everyone.
Sure. So the concept of inferencing is basically once you have trained a model, you want to deploy it into production so that you can use the predictions from the deployment to integrate with your own application to improve your end user experience, right? So inferencing is basically running online predictions.
Fascinating. So when you say the model has been trained, I'm assuming I could bring my own model to this. I could train my own model. What are my options for the model that I can actually bring into serverless inferencing inside of SageMaker?
That's a great question. So today on SageMaker, we support 1P algorithms. So SageMaker has its own algorithms that we support. Then there are ML optimized frameworks that customers can use. And then customers can also bring in their own container and own trained model and then deploy on serverless. So customers get the breadth of all the options and the flexibility to choose whatever option that works best for them.
So is there a particular set of customers that would benefit from this? I mean, is there anything that this isn't best suited to?
Yeah, that's a great question. So as I said earlier, serverless inference is particularly useful for intermittent or infrequent kind of workloads. So let's say if you see traffic from Monday to Friday, and then on weekends you do not see traffic, in that case, serverless inference can significantly reduce your costs as well. But at the same time, it also really scales fast. So it helps address those peaky or spiky kind of workloads. But in cases where you have steady throughput and steady traffic, in that case, SageMaker has other options as well, such as real-time inference, which is instance-based. So if you know that you're going to get 100 requests every minute for throughout the day, then it is easier to deploy on an instance. But in case you do not know what is that traffic pattern is going to be, and you do not want to over-provision instances, in that case, serverless makes more sense.
So I guess that it's not just the provisioning. It's I'm guessing there's a certain segment of customers just don't want to be bothered with provisioning and managing infrastructure, right? That's where the serverless part comes in, right? Can you speak a little bit to that?
Sure. So the other thing that is really cool about serverless is customers do not have to manage any of the infrastructure, right? So today, if I have to deploy a model into production on an instance-based endpoint, I'll first have to identify which instance to choose. I have to do load testing, and I have to identify how many instances to choose. I have to manage the scaling policies, right? So serverless kind of takes away all that undifferentiated heavy lifting away from the customers, and SageMaker manages all of the underlying infrastructure, right? So customers basically need to provide us a memory configuration, which is dependent on the model size that they're using. And based on the memory configuration that they provide, we'll automatically assign virtual CPUs or compute resources under the hood. And then we'll automatically scale in, scale out, and scale down to 0. So customers are only charged for the amount of compute time that they're using, and they are not charged for any of the idle time. So that's the key benefit of serverless inferencing.
So this instantly makes me think of one of the classic problems that these type of workloads run into, which is that maybe I have something that's intermittent work that I need to do. Like for I could go weeks without any work to do, but then periodically a huge batch of jobs will arrive that I need to get through. How fast does this scale out? Let's say I suddenly have a million jobs that I want to do, and I want to go from zero infrastructure to, let me see if I can get through these jobs really fast, and then scale
Yeah.
back to zero again because my job is done.
Yeah, means I think it'll depend on the container image and the model that you're using, because with serverless, the one thing or the one trade-off that you typically have is cold start time. So every time there is a new request after a certain period of time or during scaling, at that point of time we'll have to spin up the compute resources again and then load up the model, right, and start the container image. So in that case, there is going to be an initial cold start time, and that'll depend on the total model size that you have, which you're using for inferencing. So if you are scaling, let's say from 10 to a million requests, in that case, obviously there is going to be a cold start time, but it will be in the order of seconds. It's not going to be a lot. So it does scale fast.
That
Um,
sounds amazing.
Yeah.
That instantly stands out to me because, like, I know that if I wanted to provision a bunch of GPU instances or other like hardware, or even like if I wasn't in the cloud, if I had to bring in all those hardware to try to run through a machine learning inferencing job, I'm not going to get that set up in seconds. That's for sure. And so what I'm hearing here is less overhead in terms of going from nothing. I'm not paying anything to, now I have a big job to do. I get that job done. I can go back to paying nothing again after the job is done. That sounds amazing.
yeah. So definitely. So it means, and that is why serverless inference is more suitable for like intermittent workloads, because it scales really fast and then scales down really fast. Um, and yeah, and you're only charged for the time that you're using it, right? So that's the key benefit. Yeah.
Cool.
Are there any other challenges that SageMaker solves, or have we pretty much covered all the bases here?
I think the key advantage with SageMaker is that it offers a breadth of inference options. So we have real-time inference, which is instance-based, and it's suitable for very low latency, high throughput kind of workloads. Then we have asynchronous inference, which we launched last August, which is suitable for computer vision types of workloads, wherein you have larger payload size and longer processing time. Thirdly, we also have batch inference, wherein you can do offline batch jobs and then save the results in a S3 bucket. And then now we have serverless, right? So within SageMaker, you have these four model inferencing options, and we have put a lot of effort to make sure that the overall experience is same across the different inference options. Plus, the other key advantage is that you can use the same container image and you can deploy it on an instance-based endpoint and also real-time endpoint. Instance-based endpoint and a serverless endpoint. You don't have to make any changes to the container image to make it compatible with the underlying infrastructure. So that's a significant benefit, right? So today, let's say if your traffic is intermittent, so you deploy in serverless, tomorrow it becomes stable and you want to quickly flip to a instance-based endpoint. You just need to update the endpoint. You don't have to make any changes to the container image. So that reduces the amount of effort customers have to go through today, and it also gives them the flexibility and portability to move between different inference options really
That's
quickly.
That sounds amazing for a growth startup. Like, I could start out as, a startup that has very little traffic. Maybe initially I'm having an occasional inferencing job coming in, and then as my traffic ramps up higher and higher and higher, I just switch it off of serverless mode to maybe the persistent, real time mode,
Yeah.
and the solution grows with me, and I don't have to completely rebuild things from scratch on a different architecture now.
Yeah,
Absolutely.
I was also thinking at it from the point of view of, I'm getting started with machine learning and inference, right? So I'm not really cared about the nuts and bolts of the underlying infrastructure. Just do it for me, as I grow and gain confidence, or I need something, I'm going to move into more hands-on potentially, right? Not necessarily, but potentially. And it'll go with me. So I don't know about you, but I'm kind of excited to see it.
There.
ROM to stream, and let's bring up your screen share. Make sure we can all see, and take it away.
Awesome. Thank you all. So just to discuss, pretty much put to code what Rishabh and everyone else has been talking about, we're going to go through a SageMaker Serverless Inference example really quickly. So serverless inference, as Rishabh said, is one of like the 4 main inference options that we're offering at the moment. But the great part is a lot of our inference options, they're very similar in the fact that there's not much code change or infrastructure or like technical change that takes place. And we recently offered support through the SageMaker Python Sdk, which is an open source library. And by the way, you can find all these notebooks in a link that will be shared later. But we offer support through the Python Sdk essentially to pretty much easily bring any models that you have, especially for popular frameworks. So we have 2 main SDKs that we work with, the Boto 3 SDK, which is the general AWS Python SDK. And originally that was what was supported in preview, but now we offer support for SageMaker Python SDK, which makes it really easy to work with 1P containers that we support, as Rishabh said. So think of these as your popular frameworks. For example, if you have scikit-learn, TensorFlow, PyTorch, Hugging Face, anything of that sort, pretty much, we already support, and you can both train and deploy models. So whether you have a pre-trained model that you locally brought, or if you want to do training on SageMaker as well and just deploy it directly to an endpoint, the Python SDK makes that process very easy. And if we go through this notebook, we see those steps. Here I'm dealing with a regression problem. So the California housing data set is a pretty popular regression problem that we worked with in the past. And all I'm doing here is setup that's common to all of SageMaker, whether it's real-time inference or serverless inference. We integrate directly with S3 to pretty much grab our data, store our model artifacts. Here, as you can see, I'm pulling in that California housing data set, which is publicly available. I'm creating that data frame for us, and I'm going to be building a simple regression model. So here, I'm doing my model training on SageMaker itself. That's optional. You don't have to. You can bring your own pre-trained model if you want. But in this use case, since scikit-learn, as you can see, supported out of the box by SageMaker, you can simply pass in an entry point script, a training script, which has your model. In this case, I'm doing a random forest regression model that is pretty much going to be predicting median house value. I'm passing in that entry point script. A training job is launched. This estimator object is pretty much where the crux of all this training and the model data is captured. So as I pass that in, keep in mind you can do this for TensorFlow, PyTorch, or Hugging Face, all containers supported by SageMaker. As I pass it in, I come to the part that distinguishes a serverless endpoint. So as Rishabh was saying, with serverless endpoints, the infrastructure is taken care of for you. All you have to do is provide 2 parameters in memory size and max concurrency. Max concurrency has now been increased to up until 200, which is the max concurrent invocations for a single endpoint. And memory size, I've listed out the 6 options here that you can select from. And essentially you can go like any route with these 2, depending on your use case. Depending on your model size, generally what we suggest for memory size is your memory size you pick should be at least twice the size of your model. And then max concurrency, based off the traffic pattern that you're expecting, you can identify that. Here it's just set to the max just for the sake of it. But in this serverless inference config object, pretty much, very simply, you can create this object and pass that into your endpoint to pretty much tell it, hey, this is the configuration I want. And this is how SageMaker understands you're dealing with a serverless endpoint rather than a classic real-time endpoint or anything of that sort. So once I pass that in, you notice I'm sending that object in here to deploy my endpoint. So this deploy call, it simply deploys and creates that endpoint. So the main value and the benefit that came from using the SageMaker SDK, there's normally 3 steps: model, endpoint config, and endpoint creation. You can do this all through the UI. You can do it through the Boto 3 SDK. But if you notice, I didn't have to deal with any API calls that were like create model, create endpoint config, or create endpoint. The SageMaker Python SDK essentially abstracts all that out. All it requires of you is to provide that one inference config object, and then you can simply deploy it after you pass in that object. And if we want to see inference, as we were talking about, inference at the end of the day, machine learning is nothing without being able to predict on something, right? So I grab a sample data point here, I grab that payload, I grab my endpoint name, which you should be able to see in endpoints listed here. And once again, all of this is, you could easily create through the UI as well. If you have your model data, endpoint config, you could specify all of that there and create an endpoint from. And if I get here, I take my endpoint name, I'm going to send in a sample request. This will take a second to load, but as that loads, you'll get a response from that. And we should be able to see, you can monitor this endpoint right here and its invocations through your CloudWatch metrics here. So if you have
if I could interrupt for a second, Rashad talked earlier about the cold starts. So I'm assuming, like you said, you get a response back. Is it faster the second time I run this?
Yeah, of course. So if we iterate through this right now, as you can see, it performs pretty comparably to real time.
Yeah.
There's a bunch of factors, for example, like the region I'm in, the container that I have, the model size that I have. Well, there's cold start with any serverless. It's just you can control it by working with these two parameters here. And more importantly, you can optimize your own model and container to also deal with that. So
well, even just seeing that in action, it looked like it activated really quickly. And then once it was active, I hit the endpoint again. I get the response back almost instantly.
Yeah, definitely. And in this use case too, I just started up Studio. This whole notebook was warming up. So like I said, there's a plethora of factors. There is cold start with any serverless solution, but SageMaker Serverless Inference, there's numerous optimizations that you can do at the model, container level. And then obviously there's unique cases when you're dealing with heavier models that you can do more framework specific kind of options as well. So there's a number of routes you can take. Cold start is a thing with all serverless solutions, but once again, there's always like a workaround that you could kind of think of there, depending on your traffic. Cool. And then the other thing I wanted to say is just in regards to all of that, another way to evaluate like your invocations and all that, you can see all these metrics here. You can view these logs, view instance metrics, view invocation metrics. This is all in the UI that we support. You can track all these CloudWatch metrics, which will be in the docs, for pretty much being able to monitor your endpoint, similar to real-time endpoint. So if you've already worked with SageMaker before and used real-time inference, in reality, nothing changes. All you're doing is providing these two options, and you don't have to manage the instances anymore. You don't need to worry about auto scaling. You don't need to worry about saying, hey, if I hit this number of traffic, how do I scale out? How fast do I scale out? You'd have to create a custom auto scaling policy then. But here, this is all taken care of underneath the hood. The only time you really ever have to see the name instance type is if you're training on SageMaker. But in regards to inference, all of the instance related work is abstracted out, and that's where the power of it comes in.
So even though this is all serverless and I'm not worrying about infrastructure at all, I still have that observability into what's going on behind the scenes.
So to an extent, right? So if you have if you have invocations, memory util, CPU util, you can see all these different types, and there's a summary list of all the invocation metrics on the documentation page. But to an extent, you can see all of those. Obviously, the whole point was to abstract out some of that infrastructure-related work. And that's why you can't see everything per se. Yeah. Just like in real-time inference, you can't see every single detail that's happening there. But in serverless inference, model setup time, for example, is a new metric that's been published. That tells you how long it takes to load up your model. That's unique to serverless inference. But other memory util, CPU util, invocation metrics, we publish those. But a lot of the stuff that's taken care of underneath the hood is also not fully shown just because it kind of defeats the purpose, right?
Yeah, I don't want to see those things. I don't want to know. All I want to know is that my thing is getting done magically, and I don't have to worry about the hardware anymore.
Yeah, I don't know. I get curious sometimes to take a look.
Well, this is really amazing. Before we run out of time, is there anything else you'd like to tell us about this service? Like, where should I go to get started with this? Is there some code that I can that I can use to get started with this?
No, definitely. So a great place to start is our documentation, obviously. But right now we have this serverless inference repo, and I think you have the link that you can share there. But the serverless inference repo, it has an example with the SDK here. It has an example with just Boto 3 if you want full flexibility. And something we didn't cover fully here, but another new feature is Model Registry. For those of you that are familiar, Model Registry is just a place where you can dump trained models and directly deploy from them. Serverless endpoints have Model Registry support enabled now. So if you have any models that you have in the registry that you want to deploy directly to serverless endpoint, this is a quick example that you could reference there. But as we continue and as serverless and SageMaker Serverless Inference continues to grow, this repository will continue to get populated. If you feel like you have a great example, by all means, dump it in here and keep adding to it. And then we'll continue to cover it. And it's a great place to get started. Spin it up. All the notebook details and everything are there. You can take it for a spin and then adjust it for your use case as you want.
That sounds amazing. I look forward to seeing many examples and new exciting things being built on top of this serverless inferencing.
Hope so too. All right, thank you everyone, and I'll hand it back then.
All right,
cool. So we launched SageMaker Serverless Inference in preview at reInvent last year, reInvent 2021. So what's changed since up to the GA today?
So there are a lot of improvements that we made since the preview launch at reInvent last year. I think some of these Ram already covered in his demo. Firstly, we have increased the max concurrency limit per endpoint. And by max concurrency, we mean the number of concurrent requests that endpoint can handle at a given time. That is going up from 50 to 200. So that means that customers can bring in high throughput, high traffic workloads on serverless inference, more peaky workloads, right? So that's one improvement. Secondly, as Ram mentioned, we added model registry support for serverless, so you can essentially once you have built and trained your model, you can register it in model registry and then directly deploy on serverless endpoints from model registry. You can also integrate it with your CI/CD pipelines, MLOps pipelines, and build that entire MLOps workflow with serverless endpoints. That's a great improvement and benefit that customers will see. Thirdly, we are expanding to all regions, all commercial regions globally, except for China, where SageMaker is currently present. During preview, it was only limited to 6 regions. We are now expanding to all commercial regions globally except China. So that's the other benefit. And lastly, we are also adding support. We added support for Python Sdk, which abstracts away all the complexity with model deployment. So it makes it much more simpler for customers to quickly deploy models on serverless endpoints.
You guys have been busy.
Beautiful. Well, thanks so much for talking to us about your service today. I'm excited about this launch. Excited to see what customers can build with it, and look forward to talking with you again in the future. Next time there's an exciting SageMaker announcement.